Hey guys, today we'll be solving the 2004 AMC10A Problem 23. So circles A, B, and C are externally tangent to each other and internally tangent to circle D. Circles B and C are congruent. Circle A has radius 1 and passes through the center of D. What is the radius of circle B? So let's start by labeling what we know. So we know the radius of A, the radius of A right here is 1. Well, one thing we can do is let's try connecting the centers of these three triangles. So we have A to B, B to C, C back to A. So we have this being 1 and this is also 1. Well, we want to find the radius of circle B. So let's set the radius of circle B to be, for example, R. So let's have that be R and this be R. And this side would be, well, we know the radius of circle C is also R because circle B and C are congruent. So this would be 2R. And each of these sides would be 1 plus R and 1 plus R. So one thing we know here is that this is an isosceles triangle because these two sides are the same. So let's drop this point A down to BC. So now we have something like this. So let's label this point where it meets BC to be M. Let's take triangle ABM out of the picture so we can take a look at it. So it looks somewhat like this. And we have A here, we have B here, and we have M here. This is 1 plus R, and this is R. And now for the length of AB, we have something there. But there's still one piece of information we haven't used. We know circle A is on the radius, has radius 1, and passes through the center of D. So G will be like here, estimating. So let's call the center of circle D OD. So we have OD somewhere here. Well, let's see, do we know the length of A to M? Well, we know the length from A to OD is 1 because the radius of circle A is 1. And now we're trying to find this length. This length right here, we can label it as X. We can also connect B down to OD to help us solve. Well, we want to find what R is. So let's set up a few equations so we can try to find X, then maybe R. Well, we know this angle is a right angle because this is an isosceles triangle and we took A down to BC. So what we can do is we can use Pythagorean's theorem. Well, we don't exactly know what B to OD is. One way we can find it is I'll use a lighter color here. We know that this angle, this length highlighted in D in green is the radius of circle D, and that is the diameter of circle A, which is 2, which is 1 plus 1. And we know that from OD to B to that side is also 2 because the radius will always be 2. And we know this length right here is 1, or no, it's R because the radius of B is R. So this length from B to OD would be 2 minus R. You can see that. So now let's use Pythagorean's theorem. Let's take it first on this triangle I highlighted. So we have x squared plus r squared is going to be equal to 2 minus r squared. So let's expand out so we can simplify. This is 4 plus r squared minus 4r. We can subtract by r squared on both sides, so x squared is going to be equal to 4 minus 4r. Now we can also take Pythagorean's theorem on this larger right triangle out there. So let's take, we have this side length being 1 plus, we have 1 plus x squared, and here we have plus, or not 1 plus x squared, we have 1 plus x squared plus r squared is equal to 1 plus r squared. Now let's expand these parentheses. So we have 1 plus x squared plus 2x plus r squared is equal to r squared plus 2r plus 1. We can again cancel these. So x squared plus 2x plus 1 is going to be equal to 2r plus 1. So now we have these two equations. So we can basically just solve for each one of them. You can just use system of equations and solve. So I'll just be skipping that part because it's pretty simple. So x is just going to be equal to, or yeah, we can go through it. So x is equal to 2 root 1 minus r. And we got that from this equation right here. Well, let's see. What else can we do to work with it? Now let's plug in the x we found from here up into x squared minus up into that. So we have 2 root 1 minus r squared is equal to 4 minus 4r. So then we have 4 times 1 minus r is equal to, or no, we would plug this part into the x squared plus 2x plus 1 because we got it from the other equation. So we plug this into that and we have 4 times 1 minus r plus 2 times 2 root 1 minus 2 root 1 minus r plus 1 is equal to 2r plus 1. And now we can simplify that and let's just combine. So we have this being 4 minus 4r right there. And then this part would be, this part right here is 4 root 1 minus r. So now